So let's go over that one more time. Amplitude, if we're talking about a mass on a spring, is the maximum distance the mass moves from the equilibrium position. What is the furthest it gets away from the equilibrium position? That's the amplitude. Period is the time for one complete cycle, normally written in seconds. Frequency is the number of cycles per second. That is 1 over the period. It's generally measured in hertz, which is cycles per second. And then angular frequency is what we're going to use in place of angular velocity, because we're no longer actually moving in a circle. It just has the same mathematics. That's radians per second. Since there's 2 pi radians per second, it's 2 pi times the frequency. Let me go back just for a moment. I did want to say here, the period can be measured from peak to peak, from the very top to the very top, or from the very bottom to the very bottom, or it can be measured in any other place where we go between 2 identical phase points. So I can't just go from the middle sloping down to the middle sloping up, because those aren't identical places. But from the middle sloping down back to the middle sloping down is a period. From the bottom to the bottom is a period. Anytime we go through a complete cycle, we come back to where we started. That's a period. So, the formula we get to work with is this one. It's that same, what I had before. X equals R cosine of phi, which is R cosine omega t plus phi naught. Now, for simple harmonic motion, where it's just something on a spring, a mass on a spring, we make a few changes. Instead of R, the radius, we just have X, the amplitude. There isn't an actual circle here, so we don't call it a radius. Okay? Instead of angular velocity, we call it angular frequency, and we call this the phase constant, or the initial phase, and the whole thing is the time-dependent phase. It's basically just the angle, but because we don't have an actual circle moving, we don't call it an angle, we call it a phase. And this is the displacement as a function of time. So this is a formula that we're guessing to represent displacement as a function of time. It works great for the x position as a function of time of an object moving in a circle.